The third forbidden element, manufacturing strategy. Most automakers build vehicles to sell once. Tesla may build cybercabs to operate themselves. That changes durability assumptions. Instead of 12,000 miles per year, the design may target 60,000 to 100,000 miles annually. That means reinforced suspensive geometry, modular interior components, swappable battery architecture possibilities, rapid service cycle optimization if true. This would make Cybercab less like a consumer car and more like commercial aviation engineering applied to roads. That's unprecedented in modern automotive mass production. Part 6. The fourth leak. AI-centric architecture. Perhaps the most intriguing development is internal chatter about a centralized AI compute architecture unique to the Cybercab platform. Tesla already designed its own AI training hardware, but vehicle-side inference improvements could reduce latency, improve prediction modeling, lower energy consumption per computation, increase safety margins. If Cybercab integrates next-gen onboard compute, designed specifically for autonomous-only operation, it could outperform retrofitted consumer vehicles. And that's key, because autonomy isn't just about driving, it's about predicting, anticipating, reacting faster than human reflexes. Part 7. Why permits matter more than announcements. Tesla is known for bold announcements, but permits are different. They require documentation, they require validation, they require review by regulators who are not influenced by marketing narratives. That's why industry watchers are paying attention. If regulators are comfortable enough to expand operational permissions, it suggests data thresholds have been met, incident rates are within acceptable margins, simulation modeling aligns with real-world results. That's progress you can't fake. Part 8. The economics of a robotaxi fleet. Now let's talk numbers. Traditional ride-sharing platforms operate on thin margins. Human drivers take a significant share of revenue. Vehicle depreciation eats into profits. Insurance costs fluctuate, but a fully autonomous fleet, the cost structure transforms. No driver payroll, centralized maintenance, optimized routing, AI-driven efficiency improvements over time. If Cybercab achieves even modest operational cost reductions, the impacts could ripple across urban transportation, personal car ownership models, insurance industries, city planning, infrastructure. Why this matters beyond Tesla. Part 9. The skeptic's view. Of course, not everyone believes the leap is imminent. Critics argue edge cases remain unsolved. Regulatory landscapes vary by region. Public trust takes time. Weather conditions present challenges. These are valid concerns, but incremental progress often looks invisible until suddenly it isn't. When people hear the name Tesla Cybercab, one thing immediately comes to mind: disruption. And when that disruption is tied to Elon Musk, it's never small. But this time, it's different, because behind the headlines, behind the viral clips, and behind the speculation, something very real is happening. New permits, quiet filings, regulatory movements, and whispers of engineering decisions so radical, insiders are calling them forbidding. Tonight we're diving deep into what's actually happening, separating hype from reality and uncovering why this could be the most important step yet toward a fully autonomous transportation future. Part 1. The permit that changed everything for years. The idea of a fully autonomous robotaxi felt like science fiction. Yes, Tesla vehicles have had full self-FSD capabilities in beta. Yes, millions of miles of real-world data have been collected. But there's a massive difference between assisting a human driver and removing the human entirely. That leap requires regulatory approval, not just software updates. And that's where the new permits come in. Recent filings in key West states signal movement toward expanded autonomous vehicle testing, including vehicles operating without traditional driver controls. This matters because regulatory bodies don't issue these approvals casually. Each permit represents safety documentation, hardware validation, redundancy testing, simulation data reviews, real-world disengagement reports, and insiders say these filings align closely with what Tesla has previously described as the production-intent Cybercab platform. Not a prototype, not a concept, a deployable product. Part 2. Why the Cybercab is different from everything before. To understand the significance of this, we need to go back to fundamentals. Every Tesla before now, from Model S to Model Y, was built as a consumer vehicle first. Autonomy was layered on top. It's designed from the ground up for autonomy. That changes everything. There are no assumptions about a steering wheel, a brake pedal, a human fallback. Instead, every engineering decision revolves around cost per mile, maintenance intervals, fleet scalability, AI, inference efficiency. This is not a car you own. It's a transportation node, a moving server on wheels. Part 3. The first forbidden engineering decision. Let's start with the most controversial. Eliminating traditional driver controls. For over a century, vehicles have been designed around human input, with steering wheels, pedals, dashboards. But multiple reports suggest the Cybercab platform is engineered without traditional driver interfaces. Why is that forbidden? Because regulators have historically demanded manual override capability. But here's the shift. If the system is statistically safer than a human driver, dramatically safer, regulators can justify removing redundant controls, and removing those controls reduce